All right, it is time for us to go over the topic 2 review, so we're going to do that right now. These fill in the blanks are pretty simple. Number 2, angles that are outside the space between parallel lines and lie on the same side of a transversal are same side exterior angles. Number 3, a transversal intersects coplanar lines at distinct points. By the way, this word coplanar, it just means on the same plane, which for our purposes just means not 3D. We've not done anything 3D, so coplanar doesn't really mean anything for us yet, so that's okay. Number 4, 2 angles inside a triangle that correspond to the non-adjacent exterior angles are the remote interior angles. Number 5, corresponding angles lie on the same side of a transversal of parallel lines and are in corresponding positions relative to the parallel lines. Number 6, angles between parallel lines that are non-adjacent and that lie on opposite sides of the transversal are alternate interior angles. And number 7, angles between the parallel lines that are on the same side of the transversal are same side interior angles. All right, let's keep going. Number 8, suppose L is parallel to M. What is the measure of each angle if the measure of angle 2 is 138? Well, in that case, the measure of angle 1 will be supplementary and will be 42 degrees. The measure of angle 3 will be supplementary and will be 42 degrees. And the measure of angle 4 will be 138, will be congruent to the angle we already had. Number 9, if the measure of angle 1 is equal to 3x minus 3, and the measure of angle 5 is equal to 7x plus 23, for what value of x is L parallel to M? So we can see that 1 and 5 are supplementary because they are same side exterior angles. So we make that equation. 3x minus 3 equals 180, and then we can solve that. Divide by 10, we get x equals 16. So if x is 16 degrees, those lines are parallel. Number 10, the transversal that intersects 2 parallel lines forms corresponding angles with the measures of 3x minus 7 and 2x plus 12. What is the measure of each angle? Since corresponding angles are equal, we can say 3x minus 7 equals 2x plus 12 and solve. So we get x equals 19, and then we have to plug that back in. So we've got 3 times 19 minus 7, which is equal to 57 minus 7, which is 50. So each of those angles, since they are congruent, will be 50. Number 11, the value of x here would be 180 minus 50 minus 74, which gives you 56 degrees. Number 12, it would be x is equal to 72 plus 63, which means x equals 135, since those are the 2 remote interior angles. Number 13, since 103 plus x must be equal to 152, we can do 152 minus 103 to get us 49 degrees for x. And number 14, same idea. We have the exterior angle and the 2 remote interior angles. So 66 minus 40 is going to give us 26 degrees for x. Next, show the calculations used to answer each of these questions in 2-4. So our lines P and Q parallel. We can find their slopes. We can do that based on the graph, or we can do that based on their points. If we're looking at the graph, we see that the line Q has a slope up 3 over 1, and line P has a slope up 2 over 1, so they are not parallel. And then 17 are W and T perpendicular. W has a slope that goes up 1 over 3, and T has a slope that goes down, let's see, 1, 2, 3, 4, 5 over 2. So that slope would be a 1/3 for line W and a -5/2 for line T, so no. Number 18, theorem 2-4 states that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical lines are excluded because vertical lines have an undefined slope. We can't multiply them with anything to make a number. So we can just say that vertical and horizontal lines are perpendicular to each other. So it's because vertical lines have an undefined slope. All right, number 19, write an equation for each line that passes through 2, 7 and is parallel or perpendicular to the line y equals 3x minus 6. So to find the parallel line, we say, well, it's got to have the same slope, so it's got to be a y equals -3x plus b equation. We can put in the coordinate points 7 equals -3 times 2 plus b. So 7 equals -6 plus b, add 6, and we get y equals -3x, our slope, plus 13, since 7 plus 6 is 13, which is equal to b. So that's our first equation. Then for perpendicular, the slope is going to have to be the opposite reciprocal of -3, so the slope will need to be 1/3. So we've got y equals 1/3 x plus b. We can put in the point 2, 7. So 7 equals 1/3 times 2 plus b. 7 equals 2/3 plus b. And then we'll subtract 2/3 from each side. 7 is equal to 21 over 3, 21/3. So 21/3 minus 2/3 is 19/3 equals b. So our equation would be y equals 1/3 x plus 19/3. So here are our two equations. All right, going on, write an equation for the line parallel and the line perpendicular to the given line passing through the given point. So same as the one before, we've got the equation. The parallel would use the slope of -5 and the point of -4, 2. So 2 equals -5 times -4 plus b. So -18 equals b. So y equals -5x minus 18. And then for perpendicular, we will use the opposite reciprocal slope. That would be 1/5. And the same point. So 2 equals -4/5 plus b. 2 is the same thing as 10/5. If we add 4/5, we get 14/5 equals b. So our equation is y equals 1/5 x plus 14/5. Down here we have to find the measures of angles A, B, and C. We can find A by doing 180 minus 112 minus 33. So A is going to be 35 Now we know that this is 35. We know that A, 71, and B make a 180-degree angle. So 180 minus 71 minus 35 is going to give us 74 degrees for angle B. And then angle C we can find because we have two of the other sides of the triangle. So angle C will be 66 degrees. Down here, write an equation relating to the measures of angles 1, 2, and 3. Well, angles 1, 2, and 3 form a triangle, so we can say angle 1 plus angle 2 plus angle 3 equals 180. I'm sure there are other things that we could say as well, but that's one of them. And then write another equation relating the measures of angle 1, 2, and 4. Well, 4 is the exterior angle, and 1 and 2 are the remote interior angles. So we can say angle 1 plus angle 2 equals angle 4. 9.1, determine whether each figure is given, sorry, I can't read. Determine whether each figure is the given type of figure. So, of course, we have to find all of the side lengths and all of the slopes. Although in this case, since we're just finding out whether it's a right triangle, we just need to find the slopes here. Let me grab something real quick. When we find the slopes here, I'm not going to do these problems because they take a while, but when we're finding the slopes here, we will find that they're opposite reciprocals, we will find that they're not opposite reciprocals. Not opposite reciprocals. So no, that's not a right triangle. Right? Same thing in 6. To find out whether they are equilateral, we're going to have to find all the side lengths. And when we compare those side lengths, we can say no, not equilateral. They are not all the same. Right? Same thing in number 7. To find out that it's a rhombus, it needs to have, when we find the side lengths, they need to be all the same. And when we find the slopes, they would need to have 2 pairs of parallel. And when we find that out, we find that they do, which means that that is indeed a rhombus. And finally, give all the possible names for the following figures. Well, this one has 2 pairs of parallel sides. We can see the slopes here, so it is a parallelogram. It's also a quadrilateral. Then we have to check to see whether it's a rectangle or a rhombus. But since the slope here is 3/1 and this one is -1/4, it doesn't have right angles, so it's not a rectangle. We can see that the sides are not the same length, so it's not a rhombus. So quadrilateral and parallelogram are the only 2 names for that figure. Down here, we have obviously a obviously a quadrilateral. If you consider a trapezoid to be in this mix, we can see that these sides both have a slope of -2/3, which means that this is having at least one pair of sides parallel, so it is a trapezoid. But it also has the other pair of sides parallel, 3/2 and 3/2. So it is a parallelogram. It also happens to have all the sides the same length, and we can see that because all of these triangles on the sides are like a 2-3 leg triangle. So all the sides are the same length, so that means it's a rhombus. And because all of these angles are right angles, we can see that from a 2/3 slope, or sorry, a 3/2 slope and a negative 2/3 slope. They're right angles, so that would be a rectangle. And since it's a rhombus and a rectangle, it's also a square. And even it is also a kite, because since all 4 sides are the same length, that means that there's 2 pairs of adjacent congruent sides. Here's a pair of sides that are adjacent and congruent, and here's a pair of sides that are adjacent and congruent. So this shape is all of them. And that's all I've got for you. Hopefully this helps. Hopefully you are ready for the test tomorrow.